Hi everyone, this is Shannon Williams from Rancher Labs. I am excited to welcome you to today's online meetup. I am here with my co-presenter, Darren Shepard, and we're going to be talking today about using Docker Compose to deploy applications that consume microservices, and talking about Rancher, talking about all of the work we've been doing lately on application management, service discovery, and lots of work with Docker Compose. So, first of all, I want to thank everyone for attending today's session. It looks like we're going to have a great turnout and lots of people. Again, my name is Shannon Williams. I'm one of the co-founders here at Rancher. If you have attended any of our online meetups before, you've probably heard me and met me, but for everyone who this is your first time, welcome. On the line with me is Darren Shepard, our chief architect. He's going to be doing all the demos and really getting into the weeds on microservices, Docker Compose, Docker itself, Rancher. Darren, you want to say hi?
Hi, this is Darren.
All right, so we are all here, and hopefully you're all there with a nice cup of coffee and ready to learn a little bit about Docker Compose and what we're working on here at Rancher. So before I get started, I do want to just kind of set a bit of expectations. This is a meetup where we're not really here to do a traditional webinar, something we say every time, but if you've attended one in the past, hopefully you can verify these are a little different than your typical talking marketing guy webinars. We're going to be going through a few slides, but by and large, this is meant as a technical session where we demo product, we answer questions, we really stick around as long as you need us. So we will be here until all of your questions are answered. We are going to try and get through most of the content early, but these while they're scheduled for an hour to an hour and a half, we've certainly seen them run long. So if you're at all worried about any content or missing anything, we will be recording today's meetup and posting it on YouTube. So if you miss anything or you have to run to a meeting, don't worry, it'll all be out there. But hopefully you're ready to ask questions, to get engaged, and to really see this as a participatory event. You can see the hashtag Rancher Meetup. Feel free to tweet about what you're seeing and talk to each other on Twitter. There's the software you use, GoToWebinar, is not great for user-to-user chat, but feel free to meet up on Twitter and talk about what you're seeing, and hopefully you can meet other people interested in the topic. So there are a couple rules for the meetup, and these are a little different than than what we would expect in a live meetup, obviously, because we can't hear you or see you. So first of all, questions are always welcome, and with GoToMeeting, GoToWebinar, there's a good question interface that allows you to type a question. I will be scouring these as Darren is doing his presentation, and he'll be trying to look at them as I'm doing my presentation. And we'll interrupt each other with questions that you're asking. We'll try and put them, get them answered in a way that makes sense. It doesn't disturb the flow too much. But if we haven't answered your question, be sure that we will, and we'll certainly be answering it at some point. If the question is something we're going to be addressing later, that may be why we haven't immediately discussed it. So fire away with questions, tough questions. Any questions about why you would want to use this, or it doesn't make any sense, or couldn't I just do this with a script, are all welcome. So don't be shy, don't hesitate. The more questions, the better. Again, unlike a typical webinar or something, we're going to be demoing a lot and demoing more than once. We're going to go into a lot of demos. So if you want to see something and we haven't shown it, ask for it. Explain your question. We'll try and demo that, and especially towards the end, we're happy to demo anything. If you attended last month's session on Rancher OS and you have a couple questions that were never really addressed, fire away. We'll spin up a Rancher OS node at the end and go into those. So we won't be going anywhere until all your questions are answered. We're going to try to keep the slides to a minimum. This isn't meant to be a marketing session where we overview a lot of things. We'll try to set context. I'll go through a few things, but by and large, we'll be moving pretty quickly through the educational stuff. There's a lot of places to get more, there's a lot of great reading material out there on microservices, on Docker Compose, about Rancher. So we won't go into a deep information about all of these topics, but we will sort of touch on them to at least set a certain amount of context. And then, we'll be giving away some shirts. If you're interested in getting your hands on some Rancher swag, pay attention. We'll give you some chances to do that by getting involved. So those are kind of the rules. Certainly, one of the other things we're always looking for, as this is a meetup, I know we have a lot of people who've come to more than one, is topics or ideas that you'd like to see in the future. If you have an announcement that you'd like us to make, you're hiring and you're looking for Docker people, and go apply at blank.jobs@rancher.com. We're certainly happy to pass that on to everyone that's here. So use the question form. We may try to open up the audio lines to allow people to ask their questions verbally, especially if you have a more complex question. So if you'd like to answer your question yourself instead of having me try to read it, please do. I will butcher people's names, so please, apologies in advance for getting some of your names incorrect. I apologize. So that's what we're working on today. Hopefully everyone's excited about the agenda we're going to be covering, because it's a lot of, I think, really good information, and I think we're going to be showing some really cool stuff, some of which is already in Rancher, some of which you'll see over the next couple weeks as we make our next few releases. But what we're going to talk about today are microservices. What are they? What's the concept behind them? But more importantly, how do they relate to Docker? How are people using Docker with microservices? Why are the two things somewhat connected? We'll talk about Docker Compose, what it is, sort of its origins as Fig, and sort of where it sits now. And then we'll take a break. Darren will actually go through some Compose templates. He'll talk through what it looks like to build just using Compose on a single device or on your laptop, and then that'll be kind of a brief demo. We'll just go through Compose to kind of answer any questions on that. Then we'll jump in and talk a little bit more about what we're working on in Rancher around software-defined networking, service discovery, load balancing, our support for Compose, HA and system management. And then Darren will be going through a hands-on demo showing a lot of the stuff that you'll see in the next couple of releases, how we're working on environments, what we're doing around Compose, and scaling up your entire applications or services. And then we'll wrap up at the end with any remaining questions, any issues you bring up, and show you how to get started using these products, where to find them in GitHub and the like. So that's the agenda. I'm going to get started with just talking a little bit about microservices, because I think a lot of people have heard the term, and some people are using them. Certainly, some of the larger organizations out there that are adopting microservices are very well known. People like Netflix and Amazon have made very publicly sort of how they're using microservices. But at the heart, microservices are really a response to organizations trying to make application development more agile, move quicker and more aggressively towards improving their user experience, adding in new capabilities and features to applications. So if I think everyone is probably familiar with a traditional 3-tier application, and sort of how for the last say 15 years we've built applications that focus on tightly coupling layers of the stack and developing software within those layers of the stack. So typically if I was building a kind of a 3-tier application, I might have a team that worked on the web front end and developed capabilities and features there that might be client side. I'd have an app server team that built most of the logic and built all of the different capabilities of my application, and I might have a data team that sort of worked on the back end, provided the database infrastructure for these different components that make up the application. And typically these teams work together. They would they may be using Agile or waterfall methodology, but the development they were doing was really kind of segmented by layer. And by and large, when an application went from version to version, you would upgrade either the entire stack, most likely, or you would at the very least upgrade individual chunks of the application, like say the web front end or the app server. And this is all this has been very successful and very good at sort of doing tight coupling of services and tight coupling of capabilities. And if you're optimizing for stability over agility, it's a perfectly reasonable way to build applications. But when we talk about microservices, what we're really talking about is starting to, to break apart these capabilities within applications into self-standing services that can be managed. So we want to move from sort of a horizontally scalable services. Today, if I want to make my web service bigger or my app service bigger, I put a load balancer around it. I start to deploy additional nodes, or I make my nodes bigger. I make my database bigger. I can scale out sort of horizontally as I need more services. But we want to, what the idea behind microservices is to start taking these individual components and allocating teams to work on them from top to bottom and to own them throughout their life cycle. So, if I'm talking about a web, e-commerce site, there might be an inventory management system, there might be a database, some kind of a shopping cart platform, or maybe a account management or user management capability or a promotions capability. What we're doing with, what organizations are doing with microservices, they're allocating teams to work on those capabilities, and then using, generally API calls and HTTP requests to allow these services to talk to one another. And concepts like service discovery enable this to start happening very dynamically, so that services are able to find each other. They're able to really, scale independently. Teams manage them not just sort of through the development process and turn them over to operations, but rather through the life cycle of the service. And if you really drill into this, there's a lot of benefits. You get a lot more agility. You're able to really understand the architecture and dependencies of the application. You're able to take components that can be used for multiple applications and connect them out to different services. If you're running different applications, you might use the same user management framework, or you might want to use the same inventory management framework or the same shopping cart functionality. And so we really start to break these pieces down into components and make them much more manageable for organizations, much more quick to innovate. It allows for much more frequent release, dramatically easier rollback, smaller failure domains. When a service goes down, you'll know it, and it'll be much easier to troubleshoot what is actually causing the problem. You can monitor these much easier. You can monitor individual services and APIs, and really, kind of own the life cycle of these components. And importantly, as your demand changes or as workload kind of increases on individual services, you're able to respond to that dynamically. So that's really the idea behind microservices. And there's some great books out there about microservices. I don't want to go into too much depth on this. At its core, it's very nicely tied to DevOps in that it's a framework, but it's also a bit of a philosophy in thinking about how you want systems to behave and how you want your teams to work together. But among organizations that are using microservices, Docker is becoming a really valuable tool and approach to allowing components to, within these services to easily link to each other, to scale quickly, and to be portable throughout the life cycle. So to improve, Docker's benefits around, kind of being able to deploy a container locally and have it be identical to what you might deploy in test or QA or production, really goes well with microservices, because within an existing service, like in this case, maybe I'm building a service that sits on top of some kind of a Redis cluster or a distributed Cassandra database, and as I upgrade and maintain this application, kind of swapping and replacing containers becomes a great way to move from version to version. So, when I'm ready to move from the current implementation of my logic, I can basically spin up the new node, test it against the infrastructure, have it sitting on the same host in production, but keep all the traffic running through the current workflow until I'm ready to and satisfied that it's ready. In which case, I can push the traffic over to 1.1 and going to leave 1.0 there, let it sit there until I'm confident that I no longer need it and can garbage collect it and take it off the systems. But that type of approach is really a great way for managing microservices, where you expect high velocity of change, and you want to be able to really understand the relationships between the different components. So Docker itself, there's an enormous number of benefits. If you hopefully most people on here are familiar with Docker and have played with it. But they're really, from a microservices perspective, there are a number of big advantages. We talked about the consistency, the ability to develop locally, run it in test or on your VMware cluster or on bare metal that you have, and eventually deploy it out to maybe a production environment in the cloud or on a private cloud. That consistency and ability to ship an image with all of its dependencies and configurations works really well with microservices because it allows for rapid change, and that rapid change is augmented by the fact that containers spin up very quickly because you don't have to run a lot of configuration management, because you don't have to boot a full virtual machine. You can just implement a new container on existing underutilized virtual machines or on spare capacity that you've allocated. You can really create more capacity for a service in milliseconds, and the kind of time where it can actually take load off of existing services. And so as we start talking about Compose and we start talking about application architectures, you can start to see how auto response and how health checks could be used to allocate more workers into pools of resources or into pools that make up services. The other thing that makes I think containers very ideal for systems like for microservices where you have a high degree of change is that typically if you're using virtual machines, upgrading from one version to the next requires you to spin up a whole other set of resources and image those resources and then eventually transfer the workload over to them, which can be costly. It can be, it makes rollback relatively difficult. It's usually, most of the changes have to be done in multiple places in the sense of, you have to update the network, you have to update your load balancers, maybe your CDN. You have to make changes in lots of places to sort of shift from one virtual machine to another. With Docker, a lot of that existing infrastructure can be kept in place. A lot of the existing, networking rules, the load balancer policies, they can either be, made dynamic and integrated with service discovery, like we'll see later today, or even if you're still using things like ELB or a physical load balancer, you can maintain the same port forwarding. You can use the same IP addresses and make these production upgrades dramatically easier without ever having to really make changes to your VMs or your hardware or wherever it is that you're running the code. And all of this kind of drives to, the other advantage that with that portability and that ease of definition, you really get a very good way of isolating these services as you move towards service discovery and microservices that are dynamic. So, microservices are a very specific approach to taking applications and making them much more usable with high velocity change. Docker makes it easy to provision them, but Docker Compose, which was formerly Fig, is a great and really impactful approach for starting the process of defining these relationships, because as you move from kind of talking about an application as sort of just a simple 3-tier application to something that might have 5, 7, 9 different components or might be made up of multiple system services, being able to define those relationships and have them consistently move with the code you're developing throughout its lifecycle through testing becomes really beneficial. So Docker Compose is effectively a YAML file. It's something you create that describes the different images and Docker containers you're going to be using for different components within a service. It allows you to talk about relationships between those services, and any variables or any kind of things you need to provide to the container when you're booting it up, any dependencies. All of that gets bundled into the Compose file, and a Compose file can be created by the developer team that's working on a service. It's portable in the sense that it can be deployed to your source code repository and pulled down really by anyone that joins your team or wants to test and deploy the application. And once you pull it down, you're able to spin up locally, all of these services. And as we see in a little bit, you'll be able to take that same concept and deploy it out to clusters, to resource pools, to clouds, to really any infrastructure. And it gives us a framework to start thinking about things like health checks and scale and auto-scaling and how to respond to, from an HA perspective, to any kind of deficiencies in service. So I want to stop there and sort of give Darren a chance to drive into Compose a little bit more and talk about what it does, how it works, how to create one. Darren, are you all set over there?
Yep, I'm ready.
All right, I'm going to make you the presenter and let you go through this, and I'll be taking a look at the questions if there were any asked while I was talking.
Okay. Show my screen. Okay. All right, so you should be able to see my screen, right? Shannon, can you see that?
Yep, it looks good. I can see it.
All right, great. So basically what I'm going to do, I'm just going to run through a very quick demo of Docker Compose just because, make sure, kind of everyone understands Compose because, in the next demo we'll get more into how this integrates with Rancher. We'll be showing how the concepts work in Rancher and everything. So Compose is, it was previously called Fig, now it's called Compose. It was originally started off as a development tool, just making it easy to spin up a couple of containers. So if you had something, like you needed a database and a web server or something like that, you could spin up a couple containers and build an image, push it out there. It just made it really easy to develop with Docker. But now as we kind of look forward towards running Docker in production and how to actually manage these microservices and all those things, it turned out that the Compose syntax and basically what they had created actually works really well to describe a production environment. So what I'm going to show you here first is, if anyone's ever seen Docker Compose before, this will be very familiar. This is pretty much the standard demo for Docker Compose, which is I have a web server running here, which is some Python app, and then I have Redis, the database. And so some of the important things here is you can see the links. So the web points to the Redis image, and then we have some port bindings here. So we're actually exposing port 5000 out. So once you go and you create this Docker, or this is a Docker Compose file, then it's really simple. You just basically run Docker Compose up. As you see, it's creating some containers. It's up and running. If I go and I hit the containers here, yeah. So this is up and running. Okay, so there's one important part of Compose that I want to point out is that when you look at a Compose template, let me bring it back up. Oops, sorry, Docker Compose. When you look at a Compose template, so we have two containers here, but you can also look at these as it's not just a definition of one container. It's kind of a template if you want to launch multiple containers. So Docker Compose also has this feature where you can say scale. So when you run this, basically you can say how many of those you want. So I had a container called Redis, so I can go and say, well, now I want 2 Redis. So if I say scale, so you can see it actually, if I do a Docker PS here, it started 2 Redis instances. So if you're at all familiar with Amazon auto-scaling groups, it ends up being very similar to that, where you can look at the definition of the container as kind of the template of what you want all the containers to look like, and you can just scale up however many you want. But you'll see if I go and I try to do something like, let me see, I want to scale web to 2, you'll see it will fail here, and the reason for that is because of the port mapping. Obviously, we can't have 2 of these if they're both binding to the same port. So, so this is where we've got to extend this out into a multi-server environment if we really want to be able to extend, to really able to effectively scale these things. So that's just a very quick demo of Compose, and then a little bit later, then I'll show how we're basically moving all these Compose concepts into Rancher and how this maps into Rancher. Right.
Great. Thanks, Darren. That's perfect. Just there were a couple questions about microservices that came up while I was talking. I want to try and address them quickly here. And one of the questions was from Doug Rockney. He asked, is this in the slides about speed and agility, how does the number of microservices and endpoints utilizing those microservices affect the agility? Don't you run into versioning and coupling and / dependency issues? And there's definitely there is certainly a complexity that increases, with the size of the application and the number of microservices that make it up. But typically, and this is still, very highly discussed and debated. But generally, the number of services should map pretty closely to the important components that you see demand to change relatively frequently. So as you're thinking about, how many services are appropriate, what you want to think about is, where does it make sense to allocate a group of people to innovate and to drive improvement in the project? If you're something, the system that doesn't change hardly at all, maybe it doesn't make any sense to use microservices, and you just continue with the application architecture you already have. But if you're going to see, relatively high degrees of change, and you see a big opportunity to enhance or add, special capabilities, or kind of leverage some of the work that's being done, certainly the value of having a team work on it tends to offset any kind of versioning or update issues that you'll feel with it. The other thing is that because these services understand their dependencies, as the author of the shopping cart service, I understand the dependencies. I'm actually going to test and do integration testing on my own. So any change I make, I'm responsible for if it breaks or has impact on other services. So I own the API, I own the calls that are being handled by it, and so there's definitely a different approach to testing and monitoring that gets adopted as you move towards microservices. So I don't know if that answers the question completely, but it gives you sort of an idea of kind of how to break these things apart, and especially as you're moving from sort of more traditional to microservices applications. The other question was about. Oh, sorry, Darren, do you have a question?
No, I just want to add in a comment about that. When you move from kind of a, you have like more of a not like really a monolithic, but more of like larger static services, to when you move from that to a microservices architecture, basically what happens is before you were managing like one like important service, and then maybe it got broken up into like 3. So the complexity of, because you have so many more things that you're managing, it's kind of like the complexity can go up if you don't have the proper tooling and stuff in place. And this is why Docker, Compose, and these things is a perfect fit for microservices, is because it's giving us this really easy way to deal with all of these various components. What used to be just 1, now I have 15. But this allows us to be actually a lot more agile, because before, when you just had 1, if you want to go and you deploy a new version of that service, as soon as you deploy that thing, you need to worry about what are all the downstream dependencies. I have all these people, accessing it that I might not be, aware of, or things like that. So you have to be very careful about deploying that new one. But in a microservices architecture, you have a lot more like smaller assets that are easier to deploy and manage. So what you can do is you can actually a lot of times just leave like the older service running, because you can just deploy like, a new version, like 5 instances of a new version somewhere else. You hook that up to like your load balancer, you test it out, everything looks good, and then you can start slowly moving over like consumers of the service to the new one. So with microservices and all the tools that we have built around it, it makes it easier to manage the versioning and things in a little bit more incremental fashion too.
Right. There was also a question about the kind of the transition from one big database with lots of different tables to individual services carrying their databases, and does this actually make a difference in terms of data management? Why is that preferable? There's a couple of comments I'd like to make there. I mean, really, there's certainly nothing wrong with really big SQL databases that you're kind of scaling just by increasing capacity on the box as necessary. SQL's fantastic. It's worked really well for lots of great purposes. What the idea with microservices is, though, that different use cases may benefit from different types of data stores. So, if I'm building something that requires a high degree of speed, and maybe it's a heavy read application or something, I might choose one type of database versus something that does lots of writes, but it can be distributed a lot better. So really what you want to enable in general with microservices, you want to enable teams that are actually doing the innovation on important capabilities to pick the tools that are right for them and to own them throughout the life cycle. So to own the relationship between the application and the database. And really their only external responsibility is the experience of the user, is the experience of the API and their consumers, the people that are consuming that service. So you do see more fragmentation of data, and you see that you're putting data into different places, but that's the trade-off for the agility and kind of having the right tool for the right components that drives the availability and performance of that individual service. So that's a little bit on kind of data and making the right choices on database. I know there were a couple questions that came in on Docker Compose, so I'll see if I can pull those up and answer them kind of as we go. There's a question here, Darren from Mike Goldser. He's asked, sort of, can you explain why you would do, Docker-compose scale Redis equals 2? The two Redis servers won't know about each other and won't automatically replicate. So all you've done is started, two unrelated database services. Question.
Right. Yeah. So I mean that was, so when you're doing the scaling, basically you need to be aware, like the components need to properly scale. We'll get into that a little bit more when I show how this goes into Rancher. But if you have something that's load balanced, if you scale up, if I want 5 of them now, then you probably need a load balancer in front of that. Or you need to have some service discovery mechanism that can detect that there's multiple of them and respond to it. So there's a little bit more you need to do to just make those things work. So in that example where I just created 2 Redis, you're absolutely right. Like you just created 2 completely unrelated databases. But as I talk about Rancher, service discovery, load balancing, and some other things a little later in this presentation, hopefully it'll become a little bit more clear, how you can effectively scale these things.
Yeah, so why don't we jump in? There's a couple more questions, but we'll try and we'll try and actually go and kind of address them as we go. But the last question on Docker Compose is John Campbell asked, he's thinking of using links and defining all images that we're running on a single node. Does Docker Compose promote service discovery via something like, Zookeeper or Console? Is there a native Docker Compose service discovery or capability that's there, or should you use using something else?
Right. So in terms of like kind of the Docker native approach, really what things are going towards is just simple DNS-based service discovery, and that's what I'll show in Rancher in a little bit. But if you're using something else, Console, Zookeeper, something like Eureka that's a little bit more involved or whatever, there's nothing that stops you from doing that. So any service discovery mechanism that we're currently using today can still work fine in Docker. The kind of the standard one that people are going towards is DNS-based.
Great. So why don't we jump in a little bit further on kind of talking about what we're doing with Rancher and how we're trying to address these type of things. So Rancher itself, if you've had a chance to download it and play with it, is an orchestration platform. It's designed for people who want to take Docker, running really anywhere on any infrastructure, and manage and scale services and applications using containers across it. And Rancher, at its core, really sits below Docker. It's a set of infrastructure services and capabilities like networking and storage that consumes really Linux machines from anywhere. So you can provision, a host on a cloud like Amazon or DigitalOcean or really any cloud that can provision a Linux machine and has an IP address. You can use your own bare metal servers. You can use VMware. And once you've provisioned that infrastructure, Rancher then implements a set of services across it that manage things like networking and storage, that implement service discovery, that do basic monitoring of utilization, and allow for users to deploy containers or applications or services on those clusters of resources in a way that aligns with their organization's policy. So they can you can have an individual account, you can have a project that you share with other workers, and through all of this, we really work closely with Docker to enable a native Docker experience, meaning that the Docker API works on top of Rancher. You're able to use all the normal Docker commands. You're able to use things like Docker Compose, obviously we're talking about today, but also Docker Machine for provisioning. We're working on Docker Swarm. So the user experience is pretty straightforward. Rancher installs as a container. It can run on any host, and once it installs, you connect it to your different Docker repositories. You connect it to GitHub for access control. We'll be supporting LDAP and AD for larger organizations as we finish up our alpha phase of the product. And once you have Rancher running, really the next big step is to connect it to some resources. So you can register machines directly on Rancher with any cloud provider, or you can take individual hosts and just run a run a container on it. There's a container script we give you that just deploys a container that will register that machine. We'll organize the resources based on where they're actually running and understand their relationship to each other. They're in the same location, running in the same data center. And then we implement some basic monitoring of the capacity and the availability of that capacity on a host, the performance of the host. But the resources can literally come from anywhere. So what we're implementing is sort of a way of taking resources from any infrastructure and any cloud and starting to really normalize them. Because once you have these containers, you can these machines, you can deploy containers, you can deploy swarms, and then we'll implement a number of management capabilities and monitoring capabilities around those hosts. But the real value comes in sort of the infrastructure services that get deployed. So Rancher deploys initially a full IPsec network across these hosts that are running in a given environment so that they can see each other, they can talk to each other. You're able to span individual hosts and even across data centers or clouds as necessary. And that networking starts to really make a lot of sense as you start actually thinking about applications, because once the hosts are all, it's possible to dynamically configure network connections and understand the network communication between the individual hosts. You can do load balancing. We run an HA proxy service that you can spawn and create to manage incoming requests to your hosts and your services. They can scale horizontally as the capacity on the load balancer increases. And we also implement service discovery, where as you deploy services, you can connect links, create links between those services, and those will dynamically populate the relationships between the containers. Ensure that using DNS, we're able to find the different containers that are dependent, that are dependencies for an individual workload, and all of this sort of merges into Docker Compose. So as you bring, software-defined networking, load balancing, service discovery as sort of core consistent capabilities that travel with you wherever you get resources, you can see how easy it becomes to create environments and deploy your container. So if we go back to sort of the earlier slides and talking about the users created a Docker Compose template, they've uploaded it. Now let's say they want to deploy out a test environment into the cloud provider or run on their VMware and some resources they have in Rancher. What you're able to do is take that same Compose template, add variables about scale and health checks, or maybe replace a test instance with something that you'll use for production, like switching from a SQL database to maybe RDS, and deploy this individual service or this application, whatever it is, as an entire, as both an application architecture, but also sort of the critical capabilities you need to have for running the system in production. So dependencies that something like Rancher consumes to manage, monitor, and scale the service. So that same code gets uploaded, run alongside in GitHub, and when you spin up that application now, we're going to create all of those hosts and containers, start monitoring them, and implement, dynamically the network connectivity between the different containers that are making up your application. So that is sort of taking, the concepts of Compose and then, really running with it with a standardized set of capabilities in the back end to make it, a really powerful application management framework. So I want to stop there and let Darren go through that. I'll go through some of the questions and answer them or call them out as Darren's talking. But why don't we see this working, and we'll deploy an application, and you'll get a feel for sort of how the how the functionality works. So Darren, I'm going to make you the presenter again.
All right.
You should have it.
Okay. Right, so I'm going to demo using Compose with Rancher. So what we're showing here is a lot of, some of this is what's currently available that you can download in Rancher. Some of it will be coming next week in the release. But this is live demo. Hopefully everything goes well. as we pointed out before, please ask questions. Like while I'm doing the demo, just if you see something that's weird or doesn't make sense, you just ask questions. It's much more interesting to answer questions than just monologue the whole time. So let's get started here. So just give you some context. So what I have here, I've already set up Rancher. So this is Rancher. I've gone and registered three servers. These are just virtual machines running on Google Cloud. So I have 3 servers. I already have some containers running on these. Basically, this is our network agent that's already deployed. I have this console container just so I could pop open the shell and run some commands if I need to show you some things. So the network agent, this is basically what is running our service discovery and our overlay networking. So this is setting up IPsec tunnels. Essentially, it's a VPN. And then it will also be running our DNS servers to make the service discovery and things work across servers. Okay, so going back to our demo that we had before, so we have this. There we go. Okay, so before we had, what I was running in Docker was just this very simple compose template. So I have a Redis image and a Python one. So before I could just say, what I demoed before, I just said Docker compose up and it launched that. So what we're going to do is we're now going to deploy the same template on Rancher. So first thing you have to do is before you can access Rancher, you need to set up an API key. So in here, you can just go create an API key. I've already done this. So I have an API key for this user. So if I go back here, I have a file here that has the environment. So I've set up this. This is the demo site. These are my API keys. So if I just put that into my environment here. So now, instead of running Docker Compose, I'm going to run Rancher Compose. And so the idea here is we're very much interested in, it's very important to us to maintain standard Docker interface. And so the Compose template that you can run with Docker Compose, we want that exact same template to work with Rancher. We haven't modified the syntax at all, but we have provided a different command line utility that acts and behaves exactly the same way, but it uses some of our internal or our Rancher APIs to make this work a little better on Rancher. So what I'm going to do is I'm just going to say Rancher Compose up. So you can see it opened up the Docker Compose file, so it's adding services, it's running some things. So let me go back over to Rancher and point out what this thing just did and then talk about some of the concepts here. So you can see environments. There's a demo environment here. So when I create something through Compose, there's always a project name. The project name by default is the current directory. You could change that. You could say, oops, you can say like -p foo, and now the project will be named foo. So basically what we do is we map the idea of a project to an environment. So I can have multiple environments. So I can add another environment and say, okay, I want a dev environment and a test environment. And basically what this is it's logically scoping these services, because we start talking about service discovery and who can find what and things like that. We need some context. And so that's basically what these environments are. So when I went and ran that up command, it automatically went and created this environment called demo. You can see it created a service here called Redis, and then it created another service called web. And you can see right here that it's linked together. So this one links to that. Now, in theory, when I click on this, it should actually work. So let me show you. So this is kind of the logical service. So I have these 2 services. Each one of these boxes down here is a container in that service. So if I go, let me click back over. I'll run to a different tab. This is kind of like a little bit more of our physical view. We see the host. I can see, okay, actually, I launched the Redis one over here, and the web one went over there. So if everything worked, and I sure hope it did, we should be able to, oops, I didn't actually copy that. We should be able to copy and paste this IP and put 5,000 in there. Yeah, it works. Well, man, I was so scared doing these demos. It worked. Okay, so basically what's happening there is we're hitting the demo web, and then it's going across and hitting the Redis instance there. So if I go and keep hitting this over and over again, you can see that the times is incrementing, it's persisting the state into the demo Redis. So a couple things, what's going on under the hood. This guy's talking to this guy over the overlay networking, the private networking. So you can see this IP here, 10.42. This is our own IP space. So these are Google's IPs up here. These are our IPs that we manage. So this guy is talking to the Redis node over a secure connection that goes across servers. Additionally, it's like, how did this guy know that this one exists? This is through DNS. So this is what we're starting to talk about, DNS service discovery. So when I go in here, and let's see, ping Redis. Oops, can't type Redis. Right. So you can see when I say ping Redis, the IP that's coming back, 10.42, 243.70, this is actually, I go back to the other one, that's this IP. So that's how this guy knew about that one. So this all works, all of this kind of DNS service discovery just kind of seamlessly works in the Docker environment, because as Docker introduced links, at one point they made it so they add the links to the etc host file. And so what people are starting to do is when they link containers, they just look up, if I linked it as Redis, I just look for the host name Redis. And so this, this application, which was like the demo app that was written for, for Fig, basically it just seamlessly worked in this environment, or on Rancher. Okay, so let me go back and explain a little bit more about environments. So when I went and I launched this, so I have this environment and it has these two services in it. So I can go back here. Let me go and edit my Docker Compose file. Okay, so Docker Compose. Now let's say I wanted to add another service because it's microservices. So we're just going to call another service called foo. This is just going to be somewhat nonsense. So just going to use the same thing. I just don't want to list on the same port. Okay. So this should work. But we're going to say this one was linked to that guy. This is just kind of an example of showing how we can link services and kind of create this spider web of dependencies. So once I go and I create that, now I can go and run Rancher Compose up. So once I did that, if I go back to my UI here, you can say it created this service. The service is linked to the web. So now I have kind of this dependency. Foo is calling web. Now, what's in the template here doesn't actually always have to match what is, like it can be a subset of the environment. So it's not like a one-to-one mapping. So let's see, I think, well, we'll just delete the lines. So imagine I created a separate service called foo2. So I can just go and create foo2. So basically, you can see like foo2 is linked to web, but we didn't define web. Web already existed there. But so it found the existing service, which was in the environment, and now it's linked foo2 to web also. So you can go through and start, building up a fairly complex environment by doing this. If you have multiple compose files, or maybe you just create like one massive one. Additionally, we'll be adding support, so like instead of just linking to a container, you can link to something external, like an IP or a host. So you can start building up this kind of complex dependencies. Let me just show you too. Like you can actually do this all through the UI if you wanted to just manually create services. You don't have to do it through Compose. And then anything that you do through the UI here, you can always go over here, and we'll give you the corresponding Compose template. So you can just, click export, download that thing. Okay, so now the next thing is, once I have my services here, and I have like the relationship of foo talks to web and all these different things. Now I want to start scaling. So this is where it starts getting kind of interesting. So okay, so I have a web server here, and I want to go and I say, okay, scale. So I say scale up. I can just click that button. So this is the equivalent of basically typing on the command line Rancher Compose scale whatever I just did, web equals 2. But I'm just going to do this from the UI for right now. So now when I said scale, so now I've got 2 of them. I've got 2 of these containers running. I can go, if I go and I edit the scale directly, I can just go and be like, okay, actually I want 7 of these things running. If I click OK, then I'll have 7 of them. Or if I want to go down to 1, then I can go back down to 1. But we'll keep 2 here. Now, so as someone already asked and pointed out, like, if I just go and I spin up more of these containers, they're completely unrelated. Like, why is this useful? So there's various approaches of how we can tie this together to make the scaling work. So you'll notice over here, we have support for load balancers. So this is our, basically we're spinning up HA proxy load balancers. So I could go in here and manually create a load balancer. So I give it some name, I select which hosts I want it to run on, I add some containers. So this is kind of a, a manual configuration of load balancing. This is useful for many people. But what we've done is we've taken our load balancing support and then built it into the host. So if I go back to my demo environment here, so now that I have 2 of these web servers, I really want to load balance them. So what I can do, let me go and open up. I created another Compose template here. So this was our original one. I just had the web and Redis. And now I've added one more service at the top that you can see there. So the one at the top, so we'll call it LB. You can call it whatever you want. The kind of the magic thing here is the image. If you call the image as Rancher load balancer, then we know you want a load balancer. And then we overload the syntax of Compose to describe a load balancer. So here we're going to say, okay, well, this load balancer, we're going to link it to web, which means we want a load balancer for the web tier. And then the ports, this is what we're mapping. So we have like 82 to 5,000. So you can imagine, so here on the ports for the web, these ports here, we expose this out to the internet. So anybody can see port 5,000. But what I could do is not put ports there. So if I don't put ports, basically it's going to launch that container, and it's just listing on port 5,000 on the private overlay network, but nobody from the internet can talk to it. So if I set it up that way, then I can go and say, okay, now I want to expose port 8. I want to map port 80 to port 5,000, which means it will hit port 5,000 at the web tier. Okay, so this is how you can build. You can leverage our private network. You can keep all the communication private over that, and then with a load balancer expose that, just the same way as you would expose the ports. But okay, so let me show you. So let's go and let's do Rancher Compose up. Okay, this is a different file than I'm editing, so I'm just going to point you to a different file, and then say up. Okay, so when I did that, so you can say, okay, it's creating the load balancer service. Let me go back over here. Let's see. Oops. Right. Okay, so it's over here. Load balancer. So you can see it's creating the load balancer service. Now you can see these LB agents. The LB agents are so these are the containers that we launched to actually do. Okay, let me click back over to host so I can show you. So what we're doing here is we're launching these load balancer agents that sit on the box. This is what does the actual load balancing. These are pretty much HA proxy. But so when I deployed, let me click back to the demo. So when I deployed this load balancer, you can see it's pointing to web. We've got 3 load balancer agents running, and basically it's load balancing whatever's in the web tier. If I go over and I click on load balancing here and look at the actual load balancer created, it looks like it's still processing something, but you can see the load balancer is actually pointing to demo web 1 and demo web 2. Now, if I go over back to the environment and let's say I want to scale up. So I'm going to scale up. I'm now going to add a third one. Okay, so give that a second. Okay, so now I got a third container running onto this one. I go back and I look at my load balancer. Everything worked right. Yeah, so you can see it. It's actually load balancing to all 3 of those now. So that's one mechanism of how you can do scaling. So as I scale up, it just automatically adds it into the load balancer. So that's one means. So that's a load balancer. That's very common approach of how to do scaling something. So the other approach is basically to do things based off of like DNS round robin. So let me kind of show this one. What I'm going to do here is I'm going to open up a console on one of these this web tier. So this web tier is linked to Redis. Okay, so if I go, I'll open up a console to demo web 1. Okay, demo web 1 is over here. Execute shell. Okay, so I've got dig in here. And so when I say dig Redis, dig is just a utility that will give you a lot of nice information about DNS. So in this line here, you can say, okay, Redis is mapped to that one IP. So if I go and I scale up, so now I have 2 Redis instances. Okay, so I have 2 of those running. And there, and I hit that. Yes, good. So now when I did dig again, you can see I get actually 2 answers back. I get 2 A records. So I have 2 different A records for that. So as I continue to scale this, if I, if I do, if I go, let's see, now I want 5 or 4 of them. Let's see. Here, that was too much. Just do it all at once. But we'll see. Okay. So dig. Yeah. So now I got 4 of them. So what this means is, if you have an application that's just doing regular DNS lookups, we'll do DNS round robin. So as your client is making requests out to this service, it will get a different IP each time, and then that effectively load balances. That works fairly well. But the advantage of doing like a DNS round robin load balancing is that you have no middle tier. With like a load balancing, with the load balancer approach, you kind of have that, you have a tier that you have to go through. So it's like client talks to load balancer, then it goes to service. If you go directly through the DNS round robin approach, you can just client talks directly to service, and it just kind of gets essentially a random IP. The other approach is if you have an application that needs to
Shannon, be you're having a little bit of audio problems. You're getting pixelated a bit as you're talking about. I think I've been able to follow most of what you're saying, but if anything's sort of eating up bandwidth in the background, you may want to kill that. There were actually a couple questions that I think would be worth sort of talking about really quickly here, because I think you've shown a lot of work. One of them was, from Douglas Borg, he asked, is it possible to use host networking for one of my containers and still get the benefit of the overlay network to link to the other services?
That's a great question. So basically what we're trying to do there, we kind of had this, is people want to be able to use host networking, but then still use our service discovery. So when you do a DNS lookup, it will resolve the IPs. And the way that we do our overlay network is if you log into the host, you can actually just go and ping 10.42. We add a route into the host to get you into the private network. So we don't have great support for host-based, like host networking containers right now, but this request has come up quite a bit. So we will be adding support for it. And when we do, basically you could have a container which is running with host networking, which does DNS lookups to our service discovery, which will give you IPs that are on the private network, and then those IPs, those requests will go across the private network. So I think that should satisfy your needs.
There was a follow-up question he'd asked a little bit earlier where he was saying, well, another alternative would be to expose a large port range for one of the containers. Is that supported?
Right now, support port ranges right now, like we're just doing singular ports. We should support port ranges because Docker supports it, and so we'll add support for that. But I'm not exactly sure like what would be solved by opening up a lot of ports. With the private networking, one of like the main things was to keep the traffic private. If you want service A to talk to service B, which is on a different host, you don't necessarily want to open up service B out to the internet. So that's one of the things we're doing with network today. So I don't know if that really answers your question.
And Doug, feel free to fire in a follow-up. Brian had a question. Brian Scott, he asked, how do you assign 10.42 IPs to a container with starting it in Rancher. So example, like console server requires a routable IP for its advertised address instead of using the 172 address. Any thoughts on that, Darren?
Right. So, Docker's doing a lot right now to make the networking more pluggable in Docker. And so as they continue forward with that, we're working closely with them to make all this stuff work seamlessly. Right now, what we are actually doing is we're double binding IPs. I can show you in the console here, if you can still see my screen. If I do IP add or show, basically you still get the 172.17 IP, and then we additionally bind our IP. So you still have the Docker IP, and then you have our IP. This does sometimes cause a little bit of confusion with applications, and this is why we're working with Docker to actually just make it so that we can just directly manage the IP space. Yeah.
There's another question from Salman Bassett. He asked, how do you specify scaling in the YAML file?
Right. So the scaling doesn't actually, that's not part of the Docker Compose syntax yet. I think they probably will add that. I'm not quite sure. So basically the approach of what we've done is, so if I go and look back at my service here, when I click on this, is we have this Docker Compose file, which is your standard Docker Compose, but then we also have this Rancher Compose, which this ends up being like deployment specific information, but it's also stuff that we couldn't essentially represent with the Docker syntax. So we're putting scale in a separate file. Now, with Docker labels, which was just introduced in Docker 1.6, we could actually put a lot of this information back into the Compose template as just labels, and we might support that. But having the file separate actually ends up being kind of nice, because the Rancher Compose ends up being a deployment-specific file. The scale, because your scale in production is different than your scale in dev or test. There's also other things where you can go and you can say, okay, Redis here, in dev or on my laptop, I'm spinning up a Redis container. But in production, Redis is actually the managed service that someone else. So I can put a line here that says like external equals a DNS name or an IP. So that ends up being deployment specific information. So so the short answer is some of the stuff is we're introducing a second file that ends up being specific to Rancher. Everything's optional. You don't require this file. If you just have a Compose file, then you can also accomplish deploy things.
Thanks, Darren. Just on that topic, right now, to give you a feel, we've probably got about 25 questions, 20 questions or so that have come in over the last 15 minutes. So a lot of questions. One of the ones that has come in at least a couple times I've seen has been about version of Rancher that we're showing here. When is this already available, or do we have to upgrade to get this? Well, what's the latest on it? So can you just talk about the services and environments capabilities when they're coming out? And then there was a question about if you're already running, say, 0.16 or 17, upgrading to 0. Whatever the version is that's coming out.
Yeah. So. Yeah, good question. So basically what you will see, if you go and you download Rancher and you run it today, you won't see the services tab. So basically anything that I've shown in this services view is not in the current version. The majority of this code is on master in GitHub. The client-side utility I'll be pushing out today. But basically everything that I'm demoing here will be in the beta tag next week. We typically do releases on Wednesday, and the way we do them is when we do a release, we put it in the beta, like so Rancher server :beta. And then once we feel confident with the beta, then we'll move that to the latest tag. So everything you should see here will be available under the beta tag next week. Now upgrades. So upgrades are extremely important to us, and we've kind of had to make a, kind of balance this in that we want to support upgrades. It's kind of essential. If you have an environment managing thousands of containers, it's not like you're just going to wipe it out. So we actually have a fairly good tested mechanism for doing upgrades. It dynamically updates like configuration on the servers and the agents and all that stuff. And so we've put a lot of effort into making upgrades work. But in order for upgrades to seamlessly work, we also have to make sure we don't make any non-backwards compatible changes. And so kind of the bad news is the next version of Rancher is going to be pretty significant, the amount of features and things that we put in there, that it just, we weren't able to, it just didn't make sense at the time to support backwards compatibility. So the next version is going to actually kind of require you, unfortunately, to delete your current Rancher and bring up the new one. But after that version, we're committed to managing upgrades. So it's pretty much starting May. Is the month we're in? Yes. So starting May. So I think the release that we have next. So the beta tag that we'll have next week. After that, we will ensure that each release is upgradable.
And just on that topic too, the current version of alpha of Rancher, it's definitely important to say this is all alpha code. We started Rancher last year. We've been working on this code for some time, but it's still pretty early. There's lots of changes that are happening, to different capabilities and functions. I mean, if you'd seen this a month ago, there wouldn't have been load balancing, private registries, services. So, very high degree of change happening within Rancher. We love feedback, love people to take it, download it. Obviously, everything you're seeing here is open source software. You download it, you implement it yourself. It's available on GitHub, and we're happy to support you through, services, issues that you put into GitHub, or we've got Google groups and IRC channels you can hit us with. But definitely, right now this is still a high degree of change. We're getting close to reaching sort of the point where we'll be moving to betas. So right now, this is all still early, but we're getting close to a beta level for Rancher. Great. So just a quick time check, guys. I know we're sitting at a little bit past 11 o'clock here in California, and we're over an hour now. Still happy we're going to be staying on the call, but just so you know, we're recording this. If you need to run, you're welcome to come back later and see any of the questions that came up later on. Okay, more questions. So there's a couple questions that came in about networking. Two specifically. One was Christopher Jackson. He asked, does Rancher's overlay networking take the place of Weave or Pipeworks? And then there was another question about socket plane that was asked a bit earlier. That was basically asking, socket plane allows you to create additional networks and subnets, and is that also possible within Rancher? I think the question was from Jedediah Montgomery. He said, what kind of SDN is currently available with Rancher? Is there flexibility similar to socket plane for defining subnets and VLAN? So, other networking stuff in the Docker ecosystem, how is Rancher similar? How is it different? Obviously, you may want to touch on some of the networking that's going on within Rancher now that they've acquired socket plane, and so we can talk about that piece if you'd like.
Sure. Yeah. Okay. So one of the questions was, the overlay networking, does this take the place of like socket plane or Weave? So basically, it does essentially, kind of overlap with those products. But if you downloaded Rancher, like we didn't actually show the full setup here, but basically when you download Rancher and run it, we never ask for anything about networking. It's not really put in the user space a lot of the lower level details about networking. And we've done that somewhat intentional. So right now, the implementation that we're using is this IPsec-based networking. It's basically a full mesh VPN. But in terms of the specific implementation, we're not, hard and fast. Like, it has to be what we've done. Weave has been really, really interesting, and I know they have some really compelling features and functionality that's coming out. And so we've been looking very closely at Weave, at possibly, using that if that makes sense. And then also with socket plane acquisition, it makes, Docker themselves is most likely will produce some type of technology that works across hosts. So at the end of the day, we'll support kind of the best of breed, and maybe if there's a couple people really like, we'll support those. The only one that we found right now that basically, that we could kind of easily integrate with, because this kind of, meets our initial goals of performance and things like that, was the IPsec-based approach. But again, down the line, that very well might change. We're very much, it's like one of the good and bad things, as Shannon said, the code right now it's alpha. When we started this, it's always been open source. from the very beginning. So as we're building this, we love people to use it, give feedback. If there's a lot of people who say, hey, I really want Weave because it provides this feature and I really want to use it, then it makes sense, we'll support it. So another question was, do you provide access to kind of like some of the lower level stuff of like creating subnets or assigning VLANs and things like that? So this one has been kind of an interesting topic for us. Is really at Rancher, the kind of co-founders and most of the engineers working here, we all come from a background of IaaS, doing infrastructure as a service. So when we look at networking, we immediately think like VPC and subnets, VLANs, and a lot of this lower level networking stuff that's available in IaaS. As we've gone into this container world, what we're seeing is we're not getting a huge amount of asks directly for that. So a lot of the networking that we're doing is we just kind of implicitly make it so based on the requirements of the application. So it's like we define the services and how they relate to each other. So we set up a private network. We can lock down the communication. And so we're basically creating the network in more of like a policy-driven approach. Now, having said that, like the framework that we have under the hood, underneath Rancher is this orchestration system called Cattle, which is pretty powerful. It actually has a very flexible networking model, but we just haven't exposed it because we're not quite sure yet of what exactly users want. Because we're not getting a huge amount of requests of like, hey, I want to create a subnet and put a container in subnet. So does it really make sense to expose it to the user? And so this is where just the feedback of what people really want really helps us a lot. So we have a lot of this functionality that we could expose that's under the hood, but right now we've kept it kind of hidden, and we're doing more of like a policy-driven approach of the networking.
Great, that's very helpful. There's a couple other questions that were about really multi-node management. Michael Choi asked, how do multi-node links work in Docker Compose? And Andrew Klemenko asked, will load balancing within Rancher work across hosts? So I think, just to be clear, maybe all of the stuff we're talking about, how does it work on multiple nodes and clusters? And maybe you can talk about that for just a second.
Yeah. So basically, from the very beginning, I think the very first problem we tried to tackle with Rancher was, how do we make cross-host networking work, and how do we orchestrate things across servers? And so basically, everything that we have works across servers. So when we were showing services, we're linking services, but there's also kind of like the more raw, if I just go and am I still sharing my screen, actually?
Yes, you are. I can see it all.
Okay, great. So I can still just go and launch a container and then go in here and link that container, like a standard Docker link, to another one as a different name. When we set up those links will work across servers. So a lot of this, before we were doing some port translation stuff with IP tables. Since we've moved to DNS-based service discovery, what you'll see in the next release is that the environment variable, if there's an environment variable for MySQL port 3306, it will tell you the host is actually MySQL, like whatever the name of the link is, and then the port will actually be 3306. We don't do port translations anymore. So all the links work across servers. The load balancers work across servers, and all cross-server communication goes over the private network. So you don't have to worry about them being exposed out to the internet.
There was kind of I don't know if it's a follow-up question, but another question on that same topic. Andrew Easter asked, natively Docker linking only works on a single host. So is the Rancher linking in Rancher therefore not really using the native linking functionality? And I think
yes, yeah.
Covered that already, but
yeah. So as Docker continues to get better support for cross hosts, then we will use the Docker links that they provide that work across hosts. So what we're doing right now is it's the same thing with ports too. Like with ports and links, is we don't actually enable the ports and links in Docker. We manage it externally. So with links, we create environment variables that look the same. So from a container, like what's running in the container, everything looks and behaves the same. But if you do a Docker PS or a Docker inspect, you will see that they're not set up. Hopefully that will change as the capabilities in Docker are enhanced.
So another question on linking and containers was from Arthur Zapparoli. Said, when you run linked containers with links from Compose, does Rancher try to start the linked containers on the same node? If not, does it kind of coordinate the network between those nodes so it's transparent to the developer?
Right, so now we start getting into basically scheduling, and this is what we're doing a lot of, so I can't demo right now a lot of the scheduling capabilities, so this is what we're working on a lot right now that we'll have coming up in the coming weeks is basically when you, let's say if I launched a container that's listening on port 80 on the host, like I've exposed port 80, if you go and you launch 3 of those, you don't want them all to land on the same server because obviously they're conflicting on ports, and so basically, we're doing a lot in terms of scheduling, so we can look at like port conflicts or do scheduling based on tags or affinity, anti-affinity, or a little bit of looking at the resources of the server. So those type of scheduling stuff, we're building that all in. So basically, in the Compose template, you'll define in environment variables that the same syntax that Swarm is using. You'll define the constraints in the environment variables of the containers, and then we'll respect those constraints when we deploy them out. Yeah.
So thanks, Arthur. Very, very good question. There's sort of a follow-up question, I think, or maybe a part of that same question was, with Swarm and Swarm's API, is there still a need for Rancher Compose? I imagine you could set Docker_host to Rancher and Rancher machine, and it should work with Docker Compose.
Right. Great question. So we very much when we talk about how the user interfaces with Rancher, we really want it to be through standard interfaces. That's why we have Compose. There's a great feature that we haven't shown called like Docker native integration, where you can actually just do Docker run from the host, and we still orchestrate it and add networking and things. And then also we'll be adding down the line Swarm support. That's just not quite in there yet, so that someone can go through Swarm. So over time, we expect that so like when you have a Rancher Compose, like you're not using Docker Compose, but as Docker Compose points to Swarm, that should hopefully work over time. So we would hope that our Rancher Compose will probably go away, and we can just use Docker Compose natively. There are some technical issues that we run into. This is a little bit getting more into the guts of it. Is that, as you notice, like in our UI here, or in Rancher, we have this concept of a service. A service is an aggregation of multiple containers. So Docker doesn't right now, like if you look at like what the Swarm API is, it's all oriented towards launching one single container. So how do I launch a group of containers that are related to each other? So this gets into some complexities you have around scheduling. This is also why Kubernetes has pods and things like that. So there was a couple concepts in order to really run this fully at scale that we couldn't quite accomplish right now in using Compose against Swarm. But these are things that we're working on with Docker of hopefully addressing these and getting it back kind of mainstreamed into Docker. Yeah. So
one of the other.
Yeah.
Oh,
yeah.
Go ahead.
Yeah.
Sorry.
No,
I think that.
You go ahead. I'll finish.
Okay. So one of the other, I think it's a good comment on Swarm. One of the other questions that's a little bit different about Rancher was from Andy Jeffries in the UK. He asked, if he's thinking about running Rancher in kind of a multi-tenant environment or sort of an environment where they're doing work for different customers or they need to isolate different users, what's the best way of doing this? Should we use a projects per customer project, or should they use environments to isolate things? Can hosts be shared between projects and environments? Are they isolated unless links are intentionally set up? Any tips around how to isolate different projects for either customers or groups internally that need to you need to access kind of some set of resources or some application, but not necessarily everything.
Yeah. So this is an area where we expect to see quite a bit of change in Rancher, especially as we get more large scale users that have kind of a little bit more complicated requirements. right now, basically what we're doing is, there is a little bit of a security concern of what if I have a physical, or I have some server and I launch containers from different tenants. Those containers, can they affect each other? Is it security? So containers don't provide as strong of a security boundary as virtual machines do. So the approach of what we've done is if you're running really in a multi-tenant environment, with different users, and you're very much concerned about security, is we have project supports. So you can go and you can create like new projects. So I can just add a new project. I'll just call it my second project. So you can go and you create another project here. My second project here, and then, oops, sorry, let me switch to the top. So then in the project, then you can add hosts. So basically, projects own servers, and those are the resources that are going to be deployed to the server. And then on top of it, then you have environments. So it's kind of what I would expect is kind of a team, like a development team would have a project, and they would have certain resources assigned to them. And then that development team could then use environments to then chop up those resources a little further, and so they can, have, maybe multiple deployments of their application on that same hardware. So that's kind of the current approach. Shannon, I don't know if you want to expand a little bit any more on that. Or?
No, I think that makes a lot of sense. I mean, really, what we're doing with projects and stuff is we're trying to address these exact issues. We spent some time recently with a large organization where they're talking about how do they go in and set up isolation between users and even start to connect this to some of their process around what containers can be deployed. And so projects is a first step in that direction. Host tagging is another step that will make some of that possible, where you can tag hosts and do things to control which who can access which services, and kind of build clusters of resources. But right now, by far the best way, Andy, to do this is using projects for individual users. They're individual customers. You can share a project with whomever on your team you want to work on it, and you can isolate the resources. You use a totally different set of tools. So hopefully that gives you good answers. There was a follow-up question from Juan. He said, what happens if you add the new project host that is already on another project?
Oh, right. So
take a virtual machine that's running in your default project, and you now stick it into your new project.
Yeah, there's actually some bugs around that right now. So I think the ideal situation would be if that host is registered to a different project, then essentially we'll move it. Not move it, like we will register it in the new project, and then we have support coming that will import all the existing containers. But I'll tell you right now, like I wouldn't do that with the current code base. So, take one host that's in one project and then register it to a different one. This might more directly answer your question, maybe what you're asking. Is you can't share a host between two projects. It's got to belong to one project or the other. So if basically under the hood, we'll force it into one or the other. This is what I was kind of saying before. Like I expect we'll because kind of Rancher, like what we're looking, like the problems we're trying to solve is how do I manage resources, containers, and things at scale. Is that we expect this to change quite a bit. I can imagine like you have like one team who's like managing resources, and then you create a different project that has access to a subset of those resources and things like that. It'll expand quite a bit, I'm sure, over time.
And Juan had actually asked an earlier question that I hadn't been able to get to yet, so since he's asking, I'll try and put it to you now, Darren. He's really asking, how would Rancher Compose work with the new extends property for Docker Compose, if you're familiar with that?
Yeah, so I mean, basically, I think it pretty much just works the same. Like, because when you say extend, it's going to open up another file and then use that as the template. So we see kind of the reason why they added extend was that you can kind of do better management of templates. And so we will continue to do that. I think it's an interesting idea and feature, but to possibly manage like a library of these templates on the server side, but we don't have any specific work around that. But the feature of what Docker Compose has right now of extends pretty much read to local file, we will support that.
Cool. Another question that came in from Richard Silver. He asked, what about management of rogue containers? As the Rancher works right now, when it goes down and he brings it back up and the agents sort of reconnect, Rancher doesn't see the containers that have been launched on them. It's sort of a similar question to what about if I have a host going and it already has containers on it and I register that container with Rancher, does it see those? And maybe you can talk about what the current state and what we're working on with native Docker support.
Yeah, and oops, let's see, maybe that was bad. Yeah, because this is actually a feature we're really, really excited about. So I can kind of demo it a little bit really quickly. Let me go over to console here. Maybe not. Let's see if it works. So basically, this is the feature that we've been calling like kind of native Docker integration. The whole idea is that we present this website and add API and command line tool or whatever to go through Rancher to deploy things, but we know from a practical perspective, people won't necessarily always want to go through Rancher. They might have other tools like Puppet or Chef or different whatever tools to manage running a container. And so basically, what we provide is the ability that you can go onto the host and you can say Docker run, and the container will automatically see that container. We'll add it to Rancher, and we will add some orchestration to it. So you can do something like you can add Docker or you can add the Rancher networking to the container, and you can take advantage of like our service discovery and everything, but from a Docker run command. And then so that's the release that we have coming out. A week from now, that mostly works. Just go and say Docker run. I'm trying to demo it, but apparently I can't SSH into wherever it was that I was, so I don't know if I'll be able to show it. So to be able to say Docker run and it pops up. Now the second thing is, can I import existing containers into the environment? And so that's what we're working on right now, and we should have in about like 2 weeks from now, I would say, is that if you have an existing environment, you can install Rancher, and then you'll see all the existing containers. Now, those containers, since they were just launched like with the regular Docker, command, it won't have, our networking or anything like that, but you can still see them, you can maintain them, you can see the like resources of them and stuff like that. So.
Darren, we've still got about, we still have more than 3/4 of the people who joined on the bridge. We've still got quite a few people here. Lots of questions coming in. So we're not going anywhere, but just another, reminder that if you do need to run, we're going to record all this. I also someone had asked how they got their T-shirt, and haven't had a chance to put up a slide, but I'll show it at the end. But really, what we're looking for is anyone who wants a Rancher T-shirt. We just need you to tweet a little bit about what you thought today, hashtag Rancher Meetup, and we'll be sending out T-shirts to the first 10 comments. So good, bad, or ugly, let us know, and we'll appreciate your feedback with a T-shirt. Okay, more questions, more fun. The next question is really about scaling. We talked a little bit earlier about scaling up and down, and scaling triggers was a question that Douglas Borg asked. He said, how can you specify scaling triggers yet? When will you be able to specify scaling triggers? And Doug, I can answer this a little bit for you. Right now, we haven't added auto scaling into Rancher, so scaling is all manual. You can scale, as Darren was showing, just clicking on the buttons. But that is exactly something we're working on. So we're working on scaling. Scaling based on a number of different triggers. Darren, do you want to talk through some of the ways we're going to be monitoring and enabling triggers, and obviously some other ways people are doing it already, just directly using their own triggers?
Yeah, so the thing is, so basically the first step that we wanted to do is just basically give you the primitives so that you can easily plug in some type of auto scaling. So, so basically if you have the ability, like we give you an API to say, okay, I want 3 of these, I want 5 of these, I want to add 1, I want to subtract 1, something like that. So if you already have a cloud, like, some type of scaling, something like CloudWatch or, what Amazon provides or some other tool that can do the resource collection and triggers, then we should make it really easy to just, plug that in and use Rancher. So that was kind of our first step on auto scaling. Give you the primitive so you can plug in another system. What we'll be doing down the line is basically monitoring all of these services and kind of what's going on with them. So everything I've shown you so far with the service discovery and scaling, we haven't really talked about health checks. And so we're doing a lot of work around that right now of when you deploy a service, you want to deploy a health check for it. And then so if I have health checks, I can put criteria around health checks of, if it slows down or if it falls within this range, add another one. And so most of our auto scaling capabilities will be kind of around health checks.
Great.
Yeah.
And Darren, just we can't see your screen right now. I don't know if that's intentional.
Yeah, I turned it off. I was trying to see it, figure out why I think it's. I really want to show this native Docker stuff, but I don't know why.
Okay, so there's another question that came in, and it was from Chris Buddy. He wanted to know if it was possible to create two-way links. For example, for RabbitMQ, it's necessary that all the instances can reach each other. And he was saying, if not, do I have to use service discovery /DNS in that case?
Two-way links. Yeah. So the thing that's interesting with links is it is actually possible through a roundabout way to do it in Rancher because we allow you to dynamically change the links. And so what we were doing before with Docker links, like if you wanted to do like Zookeeper, we had to create, kind of a circular chain. And so we would launch 3 Zookeepers that point to kind of like 3 dummy nodes. And then once everything's up, we then relink everything and then restart. And then so you can essentially create two-way links doing that way. It's kind of it's a hack. It's not the greatest thing. You have to do like a multi-stage thing. So when you look at the DNS-based service discovery, it gets a lot better. That basically what we allow you to do, and this is something that you can't do like natively in Docker Compose, is we allow you to link back to yourself. So if I can create a Zookeeper container, or a Redis or MongoDB or something like I can create a container called Zookeeper and then link it to Zookeeper. So what that means is when I launch more and more of those things, if I do a DNS lookup for the A records, I will then get a list of everything that's available, like all of the Zookeeper nodes that exist. So it would require you to do put a little bit of a script around it and things, but that makes it a little better than what we could have done before with just like Docker links, because you can't really create a link until the container exists, which causes a problem.
Another question on this, sort of on the same topic, was, is the 10.42.x.x subnet Docker or Rancher specific stuff?
Yeah, so the 10.42, that is Rancher specific. That's our subnet that we set up. And so Docker under the hood, however you configure Docker, like you have a Docker bridge and it's running on 172 or 192 or whatever IP, we don't actually care that much about what that is. We create our own subnet and overlay it on top.
Another question was actually on, someone had asked, I think it was Doug, asked earlier, about the network, and you mentioned IPsec and how we're doing IPsec. He was wondering, have we done any performance benchmarking? Are we testing anything? I know you just were doing this, so I thought maybe you'd want to talk a little bit about some of the stuff you've been working on with performance benchmarking. Yeah,
so right, that's been actually pretty interesting. We get this question a lot, and to be honest, we haven't put a lot of testing into it. Our kind of thought was it should probably be good enough, but we hadn't really tested it. So we actually just recently, we got some bare metal machines from our friends at Packet, and we're testing this. And so we were looking at pretty much a 1 gig bandwidth. So we haven't quite gotten up to testing 10 gig yet. So like that will be the next step. But right now we were just focusing on 1 gig. And so if the test that we were seeing on bare metal was if I could push about like 930 megabits of raw traffic, like not going over our network. If I switched over to our IPsec traffic, which is AES encrypted, I could push, it was like 899. So it's pretty much 900. So the difference from 930 megabits to 900 megabits. So not a huge amount of drop in terms of bandwidth. You know, the IPsec network does add some frame, like some things to the IP frame and or the Ethernet frame and stuff like that. So there is expected to be a little bit of overhead to that. So we were seeing about maybe like a 4% drop over raw. So that, seemed, we were pretty happy with that. Now, the thing that was actually more interesting than like the pure throughput that we were seeing was what does the CPU look like, because it is doing encryption. So if you're running on relatively, or newer modern Intel-based machines, they have this AES-NI support in the CPU that does hardware encryption of AES, and Linux supports it. And so on these bare metal machines, basically what we're seeing is no CPU. Like the machines were basically idle because the processor was just taking all the load of doing the encryption. The really odd thing was actually no encryption ran slower than AES, which was really odd. But it's, it was possibly just, a poor implementation of no encryption. But so we weren't seeing a high CPU. Now, when we move over to the cloud, like all of Amazon's newer instances have this support for AES-NI. So we didn't see high CPU, usage because it was just leveraging the hardware. But we did see it wasn't as fast as bare metal, obviously. But like on a T1, or sorry, a T2 small, which I think that might be like the middle T2. So it's a relatively small VM. We were able to push 1.2 gigabits of traffic, and the CPU went up a little bit. I think it was around like maybe 30% when we were pushing that much. So I don't know. So that's kind of some like raw details and stats or whatever. But kind of the short of it is if you're looking at 1 gigabyte traffic, like 1 gigabyte links, we're not concerned about the performance of IPsec. You shouldn't really see much of an overhead, even in terms of like latency of teams and stuff like that. So.
Great, thanks, Darren. A couple other questions came in. One was from Jedediah Montgomery. He had asked again a little while ago, but if there are any plans on the roadmap to get Rancher to work behind a network/company proxy. He was saying right now when he tried to implement it, he couldn't get the Rancher container to start up if it was running behind a network proxy, so it's trying to reach out to the internet somewhere. And just wanted to know if that was something we were aware of or working on, and I can tell you we're aware of it, so I'll let you answer about working on it.
Yeah, so we're aware of it and we're working on it. This is obviously a very important use case for us. We very much care about, running Rancher behind a firewall or secure networks and things like that. Kind of the complexity, the reason why we haven't done anything about it is, well, I would say we haven't done anything about it, but we haven't fully fixed it, is that the speed of development that we're running at right now, it's just far easier to be dynamically downloading things from the internet. In order for us to completely support running behind a firewall, we need to be able to package up all the artifacts. And so when you, like right now, Rancher is really easy to get up and running. You can just say like Docker run Rancher server. But actually, under the hood, we're pulling in a lot more components. There's a lot of like, we're running various different microservices and things, so there's a lot going on under the hood. So in order for us to make this work behind a firewall, it's almost more of a packaging exercise of making sure that we can package up all these things, because there's probably about 15 different assets that we have to look at, and we would like to make that really easy for our customers and everything. So we're aware of it. It's very important to us. We will fix it. I will say I wouldn't expect like within like the next month to see maybe like month and a half, much change there, unfortunately, because it's just with kind of half-assword development, it's kind of difficult to do this.
Thanks, Darren. A couple of questions from Roman Stillman. They were both really good questions. I wanted to kind of run them both by you. The first one was about Compose. And he was saying that typically with Docker Compose, a child service like web won't start if the parent, like Redis in your case, isn't running. In production, that is not always desirable that web goes down if Redis goes down. So he's asking, in the way we're implementing it, is that still the case here, or will web continue to run if Redis is down?
Well, so there's two scenarios here. Is one, when you're just bringing it up, do we wait, like when you just do the initial deployment, do we wait for the service to come up? We're going back and forth on this because there's like different opinions on whether or not you should wait or not. So I think at the end of the day, there will most likely be a label that you can put on the service to determine if you want to wait. But there's nothing under the hood in terms of Rancher and the way we do everything that requires us to wait. Like we can just spin everything up. And so we can just spin it up all in parallel because the Rancher, how it works under the hood is everything's just eventually consistent. So, you'll launch some tier which, needs some service, but if we haven't started that service, you can still start with the client. It's just they're going to get failed requests until the service comes up, and then we, dynamically update all the DNS. So that's the initial deployment. So right now we are waiting for the service to come up on the initial deployment. We'll probably make that configurable. Now, when you start looking at upgrades, and we haven't talked at all about upgrades, we're doing a lot in that area too, because how can I've deployed these 15 microservices and I want to update one of them. How do I do that? And so when we start looking at upgrades, we don't care about the state of the downstream thing. So it's like if you just want to update one service and you have 15 of them, but one of those other services you've taken down and this service depends on it, we won't really care. We'll just go and update it because you told us to. So if you tell us to update it, we'll go and update it. So we don't require services to kind of be up and running.
Thanks. So the next question that Roman asked, and Roman, feel free to follow up if you have more questions on that topic, but the next question is about load balancer. He's saying that the current load balancer functionality is focused on making a load balancer for a set of containers and then launching the load balancer on a host. There doesn't seem to be a configuration around host names and subdomains. Is this meant to be left to the end user to run something like Nginx or the Rancher private network and leverage the internal DNS? So, which is the recommended, and have that link to the load balancer containers after routing through Nginx.
Right. Yeah. So basically, the approach right now, so kind of the initial rollout of the load balancer is like, let's deploy a scalable load balancer which runs on an IP and port, and then the users can set up pretty much like the DNS support for those. So that's what we currently have, but we're not stopping there. We very much want to go into the next level of managing the DNS, and then also look at layer 7 routing, which is going to be like host name or path-based routing. We've gotten a lot of requests for that. So you'll be able to set up a load balancer and say like this host goes, this host name goes to this container, this host name goes to the other container, but still use the same like IP and port. So those features will basically be in the next round of development for the load balancer. Yeah.
Great. There was a question from Pavel. He said, in the demo you used the environment script where you set some Rancher environment variables. Is it the normal procedure you go through on the Rancher client machines? Is that the normal procedure you go through on the Rancher client machines?
I don't know if I fully understand that question.
I think his point is when you use some environment variables when you deployed the container, and is it the same when you just go through the hosts within Rancher? Are you able to use those same environment variables and things like that within Rancher? I think that was the question. Pavel, feel free to elaborate too if I'm not getting it right.
Yeah. So I'd say that like the support right now for environment variables is fairly well. So basically, what we're doing right now is we follow the normal approach that Docker Compose does, that in your Compose template, at the time that you say up, it will look at your current environment and pull in the values. So if you specify an environment variable of foo, like you don't say foo equals something, we'll resolve the value at the time that we're doing deployment. That's not totally, I mean, it's good and bad. Like, one, you can keep, like, some things on your local machine that are in environment variables that you use during deployment. Some people might like that. But then it also kind of ties your deployment to where you deployed from. So, we have some ideas around there in our environment, like the environment that you define, that you can actually define the environment values there. So if you say, like, MySQL equals, like, password equals whatever, you could put a variable in the environment in Rancher, and then we'll dynamically pull it down at runtime. That support we don't have yet. That's, we're just tossing around that design. But what we currently have is resolving the client side the same way that Docker does it with Docker Compose.
There was actually another question on the topic from Arthur Zapparoli, and he was saying, Compose accepts environment variables, but he doesn't want to keep secrets in his source control environment. So does Rancher have any way to manage environment variable secrets across nodes?
Nothing yet. This is a request that we get quite a bit. We are kind of the opinion that it's better to manage secrets through some type of file-based approach, not environment variables. Environment variables does have some potential security issues around it. And so we are looking at managing secrets that when your container starts, we put the secret, like the kind of the clear text values, in a file in the container that just that container can see, like probably on a temp.fs. So this is something that we're looking at. We're currently designing. We're looking for feedback of what people think is the best approach, but we don't have any support for it yet.
There's also a great project HashiCorp had just announced. Two people mentioned this in the thing I was going to mention as well, called vaultproject.io. It's exactly focused on this issue. Arthur, Brian, and Doug, thanks for also bringing this up in the emails. But yeah, if you're dealing with that issue, go take a look at vaultproject.io. It's brand new. It kind of addresses this
and
issue.
so this is it was a pretty cool announcement from HashiCorp. We've talking to kind of other people in the space. We know there's quite a bit of kind of development happening in this area. It's a really it's an interesting problem, and so we're looking at these other projects too. Of kind of the last thing we want to do necessarily is have to store encrypted values. So it's like, if people are providing services that do this for you and it meets your security requirements, PCI, and all that stuff, we would love to integrate with them. So secrets is a really big discussion in itself. Yeah.
So a couple other questions have come in. One is from Andreas Steinis. He said, was it going to be possible to reach the service discovery capability from the outside, not running on the private network, for management or monitoring or other non-container services? So is the service discovery going to be exposed effectively outside of just the Rancher private network?
That's a great question. We don't have any current plans right now of exposing the service discovery out. I mean, it's DNS based, so we're not quite sure, what that would mean like if you wanted to consume it outside of Rancher. Because you do have the ability to launch, basically like load balancers or containers that are exposing the port out to kind of give someone access in. But I think it's a really interesting idea. And actually, if you could share any more ideas of how you think that should look like, I think that would be really interesting. So the concept of basically, if I have all these services, how do I monitor them externally from some other service?
Great.
Yeah, I think that's so honestly that's a great point. I think we'll consider on how we can do that.
Another question, this one's from Andrew Easter. He said, would you mind explaining a little further about how Rancher can support the ability to link external third-party services like RDS or Kinesis or something that's externally hosted?
Right, sure. Can you still see my desktop?
I sure can.
Great. Okay, so as I mentioned before, I touched on this a little bit, but when we look at the services, we have this Docker Compose, which describes the service. And then we'll have this other file, which is called Rancher Compose. And this ends up being environment-specific information. And so if you have a database like MySQL, locally on your laptop or in dev and test, you might just spin up a container. That works great. But in production, you're most likely, there's a good chance you're using RDS or Cloud SQL or something like that. So what you'll do is if I have some tier here, so if this tier, let's say, was my database, I would just say external : and then what's the address of it. And so when a client does a DNS lookup, instead of it resolving to some IP that's managed by Rancher, it will just resolve to an IP that is external. So we'll give you the ability to kind of selectively say, I don't want to run this service. This service is actually some externally hosted thing.
And Andrew had asked a question quite a while ago, back to probably an hour ago, Andrew, but I finally getting to it. He had asked about, this kind of goes back to microservices, and he said, I'm interested in what your views are on the difference between a logical view of a microservice and a physical view. Is it true that one could see a microservice as a tight-knit set of interrelated processes running in containers? Or, for example, what if you have a periodically running database cleanup batch job related to a single microservice's own data store? Is that part of the same service? So any thoughts on that, kind of, Darren,
right,
you want to talk about?
So the thing is, there's some, I'll be honest, so the way that, we have a platform and we're orchestrating containers. So kind of our view of the world is at a container level. What's running inside of the container, we don't care a lot about. If you want to run fat containers, if you want to run thin containers, both of them will work. So we don't have a strong opinion there in supporting one or the other. Like, both of them will work. But I do think, since we don't have visibility to what's running, well, we have certain level, but since we can't orchestrate those as separate units if it's inside of one container, we do think it's a little bit more compelling of putting services in separate containers. We do think we get a lot more ability to do things like upgrade independently and things like that. And so if you look at like Kubernetes has a concept of pod, where it's like grouping together containers that have some relationship to each other. We're doing very similar things, but it's a lot more from the scheduling perspective. So imagine like I have service A, which is linked to service, or let's say I have service A, but then I say it does volumes from service B. What does that look like at at runtime? And so what we're doing is, if you have service A that does volumes from service B, is we kind of deploy those containers in lockstep together with each other. So if you share a data volume, you can essentially create kind of like a sidekick container that always runs next to the other one. So if I'm running a database and I'm backing up my database, files into a container, or sorry, into a Docker volume, I can create a service that says volumes from MySQL, and we'll deploy it right next to it, and then you can run your backup job. And so you can, through scheduling these containers and the relationships, we can kind of put them next to each other. There's other things that you can do with the tags of saying, like, this is the scheduling work that we haven't shown much here, but this is what we're working on. Is you can say, okay, deploy this container on hosts that have this container. So you essentially, you make sure that these containers are co-located. Now, once you have co-located containers, there's other features in Docker where you can share network namespaces, you can share PID namespaces, you can share volumes. So you can start blending these containers together so that they're a little bit more coupled than being completely isolated things. So we like the idea of moving away from fat containers, putting things into different containers, and we're trying to build a lot of support into the scheduling such that we can put these containers on the same onto the same host, share resources, do something like backing up logs, stuff like that.
Great. Thanks, Darren. Guys, we're also, just a heads up, we're coming up on 2 hours now, so I understand if anyone has to go. But still probably have 10 to 15 more questions, and more keep coming in. So Richard has asked this question earlier, and I haven't had a chance to ask it. I just asked it again. I definitely want to get to it. He said that you showed, in fact, you're showing right now on the screen how you can sort of create, Rancher creates the Docker Compose file. But he was wondering, is there any chance to be able to import the Docker Compose YAML files from the interface? Maybe people would like to import a Rancher farm, environment or recipe from someone else's made without going through the CLI and adding the YAML file to the server. So if you don't want to use the CLI, obviously you can use the CLI to do this, but if you don't want to use the CLI from the UI, will there be an ability to just import an entire Docker Compose YAML? I hope that is the question you're asking, Richard.
Yeah, so when we first roll this out, if you want to import a YAML file, it will just be through the CLI. But basically, we're moving it all server side so that you'll be able to do it through the UI. But so the first rollout of this functionality as we deploy it and kind of stabilize it over the next month, we won't be importing templates on the UI. But after that, we will support it. But it will be kind of the next round of development.
Great. Another question from Brian. He was asking, when will full documentation be updated for Rancher and Rancher Compose?
That's a great question. Yeah, we're quite aware that we're lacking on the documentation side, which is not great. So I would expect a lot of that to change. We're as we said, this is alpha. This code is alpha, and I would say we probably should have documented a lot more than we have, but we're changing things so much that it's like, we weren't quite sure if it made sense. But we were marching towards a beta. We really want to get a beta so that we can stabilize this and really make it deem it production worthy. So one of the kind of requirements for beta is that we do have proper documentation. So when will you see that? I would expect over the next 2 months.
Cool. Roman had another question he just asked. He said, in your load balancer example, you mentioned removing the port field from the web process. This would then route traffic from the load balancer to the web container over the private network and not expose web ports publicly. Does this mean that multiple web containers could now run on the same host since host port is not specified? One thing that interests me is the ability to leverage hosts with enough RAM to run multiple copies of containers, since the OS could assign ephemeral ports. If you don't specify the host port, will our load balancer containers pick up on that? Long question.
Okay, yeah, so let me answer the first part, and then I'll probably forget what the second one, and you can reread it. So the first part of the question was the, if we don't expose the port of the web container that we're load balancing, yes, it will just run over the private networking, and this does make it so that you could run, if you, let's say you deploy one load balancer and you expose that port, onto, publicly out of the host. You could then load balance, 15 of the same containers, all listening on the same port, on the same host. That will work, because that port is just local to that container. This is, and this is another reason why overlay networking and it ends up being really important in the container space, is that you really want to create this view that you're not so much tied to hardware anymore. You're just looking at applications, and they're just magically being deployed and scaled and scheduled and all this stuff. But as soon as you expose a port, you then break that paradigm. And so as much as possible, if we cannot expose it, actually, sorry, the correct term is publish, or if we cannot publish ports out to the host, then we can get better resource utilization and things like that. So with the private networking and keeping the traffic on the private network, that does allow you to spin up, X number of these things, and we don't have to care so much about the physical hosts running under the hood. If you do publish a port, then we have to look at port conflicts and scheduling. So, I might have 3 really big servers, but I can only deploy 3 tiny containers that happen to use port 80. So that does cause problems. Okay, so that was, I think, hopefully that answers the first part of the question. What was the second part?
I think I think you addressed it because he was saying that,
okay.
The thing that interests him is the ability to leverage hosts with enough RAM to run multiple copies of containers. So since the OS could assign ephemeral ports if you don't specify the host port.
Yeah. And so, and this also gets really interesting as we extend our load balancer to support host names. Is that right now it's kind of like you create a load balancer for a port on that machine. But if I can create a load balancer that runs on that port, but then you can say, okay, this host name routes here and this host name routes there, then I can reuse those ports, that port for multiple services. And then SNI, SNI is a technology around SSL where before you always had this limitation, you could only have one SSL certificate per port. But SNI, as web browsers are now, pretty much modern, everyone's updating them. You can actually now pretty much leverage SNI. So you can actually do SSL certificates too. That's another thing we're very interested in adding is SSL termination and certificate management to our load balancer.
Cool.
So we should be able to get really good resource utilization, essentially. That's kind of the moral at the end of the day.
Great. So another this actually is given our meetup type of thing, it's not exactly a question, but Bryce Kotke just posted that he works at a place called Redapt, redapt.com, and they're looking for anyone who can do cool things with Docker and Cloud. And he's got I'm going to post to the published questions his email, and he certainly would love anybody who's interested in working on this kind of stuff. So, all right, a couple more questions. We're starting to get to the bottom of them. This was from Ted Young. He was sort of more of a comment, but he was saying he'd like to see a simple, lightweight DNS that he could delegate to from an outside, higher-level DNS zone. So he could have foo.rancher.example.com, where Rancher would be delegated from example.com DNS. And I bring it up just because I think it'd be interesting to talk about that, and also as you start dealing with running these load balancing services against containers in different locations, what's the role of GSLD and global load balancing and things like Route 53. So do you want to talk on that topic at all?
Yeah, so I know right now we don't have specific development around kind of exposing out a DNS server, for this use case, but we are looking at this. It's kind of like in our next round of development as we've as we were showing Rancher and we're getting kind of all these feature requests is to support more of like when you deploy an app, like I have app, my app's called Foo. I want that to resolve to foo, .mycompany.com. And so, hooking up that DNS and, being able to have, basically like kind of some zone or whatever, which delegates to Rancher. We are looking at supporting that feature in the future. We don't have like current development going on right now for it.
So this is another question that was asked a while ago and hadn't been able to get to it. This is from Vijay Anaparetti, and he said, can rancher.yaml be used to deploy the microservices environment as done with compose.yaml, or it can only be used to scale the already existing microservices environment that has already been created with docker-compose.yaml? So I think I just bring it up because I think maybe just in case there's any confusion about where
Sure.
What is the difference between rancher-compose.yaml and docker-compose.yaml. What do they do? Do you need them both? Do you just need one? Are they compatible? Maybe just in case anybody missed that concept, maybe you can kind of cover that again.
Right. So the Docker Compose YAML is really our main entry point. So, just as when you say Docker Compose from the command line today, you need a compose file. If you're running the Rancher Compose, you also need a compose file. So that basically will always require that one file. And then additionally, if you have the Rancher Compose YAML file, if you have that file kind of available at the same time, we'll pull in a different, additional information. So when you say Rancher up or Rancher Compose up, in Docker, in Docker Compose today, like there's no scale information at that time when you say up. But if you wanted to immediately assume a certain scale, then we'll look for this additional file. So we always look for this as additional optional information for any of the commands that you're running from the command line. And I realize as I'm explaining this, the idea that the file is called Rancher Compose is actually confusing. So we might rename that file to something else. Okay.
So thanks for that question. Another question that came in from Sinath Grandi, he had asked, just maybe he was asking, should Rancher be seen as a micro OS or as a platform for managing containers? So I'll try and take that one, Sinath, just as I think I understand the confusion. So Rancher and Rancher OS are actually two separate projects and products. Rancher OS is a micro OS. That's what if you're trying to deploy Docker containers on, a very small version of Linux, Rancher OS is a great option for that. You can see the meetup we did last month. It kind of walks through what is Rancher OS and how does it work. We've actually made a lot of progress on that even in the last month. But it is totally separate and not dependent in any way on Rancher, which we're demoing right now, and vice versa. Rancher can run certainly on Rancher OS, but it can be running on RHEL or CentOS or any Linux distribution that deploys, has Docker support. So Rancher OS, Rancher, two separate projects. Rancher itself is more of the management layer. Rancher OS is the microservices the micro Linux distribution. Another question that came up a bit ago was from Joseph Jacks, and I wanted to get to this earlier, but he was asking about Kubernetes. So he said, are there any plans to integrate Rancher with Kubernetes, since a lot of the scheduling and orchestration functionality is complementary or overlapping? What is our take on Kubernetes and its evolution, especially considering it will have more kind of advanced native scheduling facilities soon? So anything you want to talk about Kubernetes, Darren, and sort of working with Rancher and Kubernetes, sort of how much they overlap, how complementary they are? That'd be interesting.
Yeah, so I mean, Kubernetes is a really neat project, really smart concepts. Like, these guys definitely know what they're doing in terms of how to deploy, how to deploy these containers at scale. And so, as we're building out Rancher, we look a lot at, towards kind of how Kubernetes has done things. Our kind of overriding goal has always been to natively support Docker and their interfaces. And so, as you see with Rancher, it's like everything is, just kind of, we're trying to use the same terminology, the same interfaces, the APIs, and everything that Docker is exposing. So, because of that, we do see a huge overlap in terms of kind of what Docker is doing with their projects and what Kubernetes is doing. The functionality does overlap. The way you interface with the system is different. So right now we're kind of really focusing on the Docker ecosystem. Yeah.
So another question,
if you want to answer.
Yeah, no, I think that answers the question. And I think that's a good answer. I mean, I think, Kubernetes and Rancher are relatively different. They take very different approaches to managing and orchestrating containers and applications. But certainly there's a lot of differentiation as well, and a lot of the infrastructure services type of things we do, are very complementary with Kubernetes. So I know of at least a few people who've been, using Kubernetes with Rancher, and I certainly don't see there being any reason that's not possible. But from a focus perspective, our focus is really on sort of more the native Docker experience. So we want to persist making it always possible to talk Docker to Rancher, and obviously with Kubernetes that's not the approach. So another question from Andrew Easter that's about sort of Rancher, and he was asking, where is Rancher's configuration actually persisted? If all of his hosts were destroyed, would all of his Rancher configuration disappear with them?
Right. So today, like if you just go and you spin up Rancher, you just run Rancher server. If you look inside that container, you'll see that we're actually running a MySQL database in there. So all of our state is persisted in MySQL. Running like the kind of the default configuration of the Rancher server container is really not the ideal setup, because the state is kind of in that container. It is put into a volume, so if you wanted to do an upgrade, it does mean like just stop that container and then start up a new one and do volumes from, and then you upgrade it to a new version, keeping the old database. But as you look at really deploying this to production, you want to depend on this highly available and all that, is you're going to basically move out the state into a MySQL that you're managing, whatever. So I know what we deploy often in our production environments is we're using RDS or Cloud SQL. So we will be putting forward a lot more information on how to scale Rancher to kind of because the way Rancher is actually designed is it's very simple to get up and running. But if you want to scale this up, you can kind of break it out into various different tiers and things like that, because there's actually a lot going on within that one container. And so, in terms of we mentioned before, we're really light on documentation. We haven't properly documented of how to, run this at scale and, have a better environment. So, kind of the short term, the thing you can do today with Rancher is you can point it to an external, when you start Rancher server, you can set some environment variables so it will go to an external database. Or if you're running the database inside of the container, you can do the volumes from approach to do upgrades.
So another question that came in was about console, and Erickson Cepeda said, he said, do you consider console as a complement in any way? And I think it's a good question because, we definitely, we have a lot of people we know that are using console, and console is a very powerful service discovery tool. It has a lot of very cool capabilities that go beyond, the native service discovery capabilities we build into Rancher. So it's definitely a complement, and if you're using console, you probably continue to use it, and you can certainly use it with Rancher. So I do think that they're not mutually exclusive, and console provides quite a bit of additional value beyond that. Anything you'd want to add on that, or should we jump to the next question, Darren?
No, not really.
Okay. So, another question. This one was from Christopher. It's actually, I would say, more of a bug fix. He was saying that, with agents placed on hosts, he's noticed at Rancher, if you're putting if you're trying to use the same host that you're running your management server or your management container on, he sometimes sees, the stats and other things are not working. So, Christopher, I would just say we actually have seen that as well. There's an issue filed in GitHub, and we'll certainly be addressing it.
Yeah, I could comment specifically on that because, basically, when you register an agent with the server, we try to detect the IP of the agent. So if you're running them on the same server, we often detect the wrong IP. So there is a very simple fix for this. I think it's somewhere in the FAQ for Rancher that there's an environment variable that you can put on the agent when you launch it of saying, use this IP. It's cattle_agent_IP. You set it to a specific IP, and then that will solve that issue. Yeah.
So yeah, thanks. So here's another question. One of the this is kind of goes back to we were just talking about Rancher OS. Synath was saying, so Rancher can run on any OS. What would be the use cases of Rancher OS, and how do you see it being used? So Rancher OS is and Rancher, as we said earlier, Synath, they're not tightly connected. They're two services that can they certainly can work with each other, but don't require it. The use cases for Rancher OS really are kind of we talked a lot about them last week, but or last month when we did that meetup. At a very high level, they're for organizations that want to use Docker and want a very clean, simple way of running Docker on Linux with Docker and being able to use Docker management to manage things like system services and other components. So if what Rancher OS is a 20 meg Linux distribution that lets you really run everything in the OS as containers, and then makes those swappable and modifiable, makes it so you can choose to deploy system services like monitoring agents as containers, or using different logs. But the really interesting thing that I would just point out is as Rancher OS matures and as Docker Compose matures, one of the things people are seeing, and we talked about this last month, was that you can define your operating system with a Docker Compose template, and you can actually say, these system services, here's my image for this OS, here's the console I want, here's the version of syslog I want, or udev I want, and I want to run these 3 different containers. all as system services that the user doesn't even interface or see or have any ability to manage. And then user sits in sort of a second Docker daemon that runs in user land. So I would just say that, as Docker orchestration and management tools become more powerful and more common, you can see the benefit of how they apply both to an operating system as well as to obviously an application and workload that runs on top of it. And that's where we think there's a lot of potentially cool stuff that can happen, and that we're looking at how Rancher and Rancher OS might be able to add some special value working together. So I don't know if that answers your question completely. Feel free to ask it again, but hopefully that gives you some thoughts. Darren, did you want to add something?
I just want to say an interesting anecdote. So Docker Compose is actually written in Python. A lot of the development that we're doing in Rancher and Rancher OS is in Go, and specifically Rancher OS is 100% Go. So we added support to Rancher OS so that you can define the system services and the whole OS in a Compose format, which essentially meant, since it was all written in Go, that we had to kind of implement, Compose in Go. And so when we actually did the Compose support in Rancher OS first, and then we're doing Compose support in Rancher. And so we were able to create the Rancher Compose command line, which is written in Go, very easily because we're leveraging the same library. And I had mentioned before that it's not really ideal that we are using. It's not really ideal that we've implemented our own Compose CLI. Like, we would have liked to just use Docker's directly. And so one of the approaches or thoughts that we have going forward is how to kind of consolidate back is talking about actually just donating our Go implementation of Compose back to the community, because that was kind of one of the things that led us down this path, was just that we needed something in Go, and it was written in Python. So just an interesting point.
So, guys, we're coming up on 12:15, 12:30 here in California. A couple more questions. This one was from Torsten Kurt. It kind of goes back to the networking performance, Darren. He was wondering about the overhead per host and the network connections across hosts. Some connections need higher throughput than others. We kind of talked about it with IPsec, but is there anything you wanted to add or talk about any kind of thoughts on throttling or on sort of prioritizing, maybe prioritizing containers and things like that? Anything you'd like to add to that?
So we don't have any specific work right now around kind of QoS and networking, but that does, I think there's definitely some interesting things we can do. We do have the ability to apply like QoS rules, like per routes between containers. Since we are kind of managing this full mesh, we can put on different criteria and things like that. But we don't have anything right now. So in terms of can one container starve another or something like that, I think it pretty much is kind of what you already currently have with Docker. Like, the overlay network doesn't really change things very much there. So it's how you currently manage it. You can basically do the exact same thing with our overlay network.
Great. So another question. This is from Arthur Zapparoli. Said, how do container updates work on Rancher? The load balancer feature provides something like 0 downtime deployment, keeping the old container linked to the load balancer while the new one is spinning up. Is that how it works?
Yeah. So we're doing a lot around upgrades right now, different methodologies, because you can do like a rolling upgrade, you can do kind of like a blue-green deployment. And so what we're trying to do in Rancher is give you more of the primitives so that you can kind of construct your own procedures around upgrade. So for example, what you can do is you can deploy, so if I look at my environment, I have some service called foo2, or let's say foo, this is a good example. So like I have foo, and foo is the DNS name. That's actually what something looks it up as. So I can go and deploy foo2, which will be the exact same. Like, I can deploy a new version of it under a different name, and I can test it out, and then I can go and rename it. So there's, in here, you can go and edit and rename the service. And so we're looking at doing kind of like it's not really atomic because things are kind of eventually consistent, but we're looking at like a single operation to take over a service. save an existing one, and then you take over the other one. So like that's one approach of like doing an upgrade of just deploying a new version of it and then taking over the other one. The other approach is basically I deploy 2 versions of the service and I start scaling down one as I scale up the other one, but they're both known under the same name. So these are the things that we're working on, and we're basically just trying to give you pretty much the primitives to do it. So you can control the scaling of services, you can deploy them as new names, you can rename them, and we'll see as we kind of finish out the code in this area of what the different other primitives we think we need to add.
Okay. So this may be, we're probably going to make this the last question. There's a few more that I haven't answered, but we'll try to get to most of them. So this one, Luis Perez Galvan asked a little bit ago, and he's asking about VDI. He's saying, would you recommend using Docker with KVM Windows VMs for VDI? Is it possible to connect these VMs, whether they're Windows or Linux, with native KVM Spice? Will each VM still need, the 2 to 4 gigs of RAM for Windows for good performance? So I don't know how much if you've played with Windows VMs and embedding them in Docker and everything else, but I know we actually, I did want to talk about this question because we are going to be having our next meetup next month. We'll be talking about Rancher VM and using VMs and containers and sort of Inception-like stuff there. But do you want to try and take on that question about VDI and Rancher VM and maybe talk a little bit about that?
Well, yeah. So there's 2 things there of actually running virtual machines in containers to provide Windows. And so we've done some fun things around that around Rancher VM. The other approach is running Docker on Windows itself. And so I actually think it's pretty interesting what Microsoft is doing in that realm. Microsoft, the Build conference actually just started today, so I expect to see some nice announcements around that. So I'm thinking in terms of, we're going to see, pretty neat container support on Microsoft, and at Rancher we're very interested in managing, kind of Windows environments too. So that's one thing in the future that should be coming. But specifically around like Rancher VM, so we have this separate project. This is kind of a proof of concept and seeing what we can accomplish, because once you have like this container orchestration platform, you can do a lot of really interesting things with it, and you can really manage all these assets, relationships, and security, and assigning resources to users, projects, and all this stuff. And so there's quite a bit we can accomplish with it, but some people still do need to run a virtual machine. So what if the container, instead of it being an app running in the container, what if it was actually just a virtual machine? And so that's what Rancher VM is actually launching containers that are virtual machines. And it ends up being really interesting because, so let's say like a VDI workload where you just have a bunch of Windows images, things like KSM, I think that's the right term, basically like the page sharing capabilities in KVM allow you to like minimize the amount of memory that's taken, so you can actually launch up a bunch of Windows machines, but they're all sharing memory. So that does actually help in like a VDI case. And then there's doing like thin provisioning. The default behavior in Rancher VM is to thin provision a volume. So some of those things can help because your base image is basically in the Docker image, but then you do a thin provision off of that, so you're sharing all the base images. So there's definitely some interesting things that we can do with VMs and containers, and I think that's kind of really on the forefront, and honestly it kind of confuses people sometimes because we're going like a couple levels of inception. But there's definitely me being a background in orchestrating virtual machines, I kind of really like the idea, and we found that it ends up being a really simple, easy way to run a virtual machine farm. Like, you don't necessarily need all the features and functionality that you would get from, like, let's say OpenStack. You need something just a little bit simpler. Like my networking is really easy. I just want to manage a whole bunch of virtual machines. So Rancher VM on, using Rancher orchestration is actually a pretty neat use case.
Cool. All right. Well, Darren, thanks for going through all that on the demo and answering so many questions. I think they're we've got a lot of questions. There's even more coming in now, but I think we'll probably wrap up just to sort of talk through, kind of, how to get started with this stuff, guys. The, Rancher is on GitHub. You can go to, github.com/rancherio/rancher and see it, download it, use it. You can also get access to OS and any other projects we have in that same directory. So this is the way to get started. It's all open source. It will always be open source. You'll be able to always kind of pull this down and use it. So we love people that file issues, kind of make enhancements, help us with anything we're working on. It's a community. Really, if you want to get engaged, let us know. If you're struggling to understand where to get started, please let us know. We're always looking for participation. As I mentioned on the chat, feel free to. We'd love your feedback. If you liked what you saw, if you have questions, kind of hit us on Twitter. You can hit Darren or I directly, and we'll try to respond as much as we can. But we'll be shipping out shirts, so please talk about what you thought and what you think of what we're doing. We really love the feedback, and any questions you have that weren't answered, don't hesitate to hashtag them with Rancher Meetup, and we'll be paying attention and try to respond. Just a bit of housekeeping. Next meetup is coming in just a couple weeks, so we're doing one May 13th on Rancher VM and some of the stuff we just were talking about. So you can register using the link below at info.rancher.com. It's quite a long one. You can also just find it on our website if you go to rancher.com, and I'll be sending it out in the follow-up email that includes a link to the recording. So you should see it sometime soon. So other than that, thanks everyone for coming today and participating. We really appreciate your time, all the great questions, and all the really nice things people were saying about using it already and liking the direction. We realize it's still alpha. There's a lot of work that's being done to harden and to make it more production ready. So if you have ideas or things you think it needs to be doing, let us know. Otherwise, thank you all, and thank you, Darren, and really look forward to seeing you all at the next online meetup. Thanks a lot.